on three logical connectives. Actually, one of them is not even really a connective. The main focus is going to be on conjunctions and disjunctions. Right, so that would be ands and ors. We'll also throw in a few knots in there, so the opposite, complementary events. We will touch on implications, at least in the early going, it's not going to be very prevalent, but as we move forward, it becomes more and more, right? So the disjunction, the and statement, only true if both parts of the sentence are true, right? The or is true if either part of the sentence is true, and if then we'll get to in a little bit, all right? But I wanted to expose you to the Venn diagrams related to these. They're pretty easy to do. You'll want to use colored pencils when the time comes. I mean, you could get away with just using a pencil right now with just like cross hatching and stuff, but down the line you're going to want to have colored pencils. I have a ton here, so when I give you the assignment, I'll make those available to you. All right. But when we talk about A with the upside down U, that's the intersection between two sets. All right. So we're keeping it very basic at this point. We're just working with two sets at a time. All right. I'll challenge you with more complicated cases down the line, but not in the early going, obviously. All right. So the intersection is exactly what it sounds like. It's really where they come into contact with one another. You look at the intersection between two roads. That's when those two roads have parts that are in common. Intersection of two lines, that's the point in common. All right. Intersection between two sets, that's the area that's in common. And we learned in the last unit that area and probability could be kind of interchangeable depending on the circumstances. All right. So when I'm looking for the intersection of A and B, let's say I call this one A and this one B. What I would be doing is taking all of A, all of B, and see where the double shading exists. All right. So that little wedge in the middle, that's going to be your A intersect B. This little piece right here. All right. In a logical sense, we would use an upside down V, but when we get into sets, we use U's instead. All right. So it's kind of weird because it's really the same concept, but in different branches of math and even computer science, they use different symbols. So it's just the nature of things. All right. So when we talk about A union B, all right, so the union of two sets, what we're really talking about is combining them into one larger set. I mean, it says it right there. The typical example that I use is the concept of marriage. When you marry two ideas together, that could mean one thing, but I'm actually talking about matrimony, like two people getting married. One person has $10,000 in the bank account, the other person has $5,000 in the bank account. When you unite the two sets, now they have a total of $15,000. They're split among the two bank accounts, but it's still a combined set. Unless there's prenuptial agreements involved and stuff. You get into the law and all that. It gets overly complicated. I'm taking it back to like a third grader's understanding of marriage, right? Just keeping it simple. Two people, and they get rings and stuff, and then they go on their merry way. Right? So, but just to be a little realistic about it, there is sometimes when we unite two sets, I'll just do it over here. There is sometimes, I have auto shading on, let me just get rid of that. You have one person with their money in the account, let's say, again, $10,000. And then another person who's got their money in the account, I'll just leave the shading. And that other person's finances could get absorbed by the first person's finances. All right. So that would be the instance. So this is another case of a union. Where one set dominates another set. I'll figure out the shading later on. But once it's basically the instance where one person has $10,000, another person has $5,000. They get together, create one bank account where all the money goes, and it's in the name of person number one. All right. So that would be another instance of a union. But in this case, where we assume that there is just some overlap, what we would do is we would take person A, all their earthly belongings, person B, all their earthly belongings, and the union would be any part of the Venn diagram that's shaded. All right. So the first one is just the overlap. The second one would be any part that's shaded. Hated, shaded. All right. As cool as this looks, I gotta get rid of it. Delete. All right. Yeah, so not just the overlap, all of it. So really, I'd be looking at one final set that's everything that's covered with some shading. All right. Whereas in the first case, it's anything from one set that overlaps with anything from the other set. All right. So that other example of a union, we would be talking about everything that's in this circle. The typical example I use, and we'll get to the actual pure probability in probably like a week, maybe a few days. But if you roll a die, right, six-sided number cube, labeled from 1 to 6, and somebody asks you, what's the probability of getting an even number and or a 2, an even number or a 2? If you count all the even numbers, you're also counting the 2. So you would have accounted for the second set just by stating the first set. All right, so that's kind of a more practical example of this second union diagram here. All right, whereas if you roll a die and a simple case of rolling a die, and you're looking for a number that is prime or odd, right? You'd have some overlap, but you wouldn't. No, actually, that's pretty much the same example. One's covered by the other because all the primes would cover the even. So I'll think of a better example down the line, but basically there's something in common. It's just a question of whether everything's in common or only a little bit. All right. The complement of A is probably the easiest one. All right. So that little tilde means not. All right. So not A. So if I'm calling this set A, I haven't identified any other set. That other circle could be B, it could be C, it could be Omaha. It really doesn't matter. If I say not A, I'm saying everything except for set A. All right. We're only working with 2 sets at a time, at least in the early going, but there could be 100 different sets. All right. So if I say, in this class, for example, let's define A as a person who's wearing a white shirt or sweater or sweatshirt. All right. Only because I see 2 of you. So it kind of works out. So A would be you 2. Not A would be everyone else. All right. And we could define everybody else as one set of everybody else, or we could define it as each person being their own set. All right. In which case it'd have 3, 4, 5, 6, 7, 8. 8 different sets that meet the requirement of not being A. All right. So in terms of the shading, I wouldn't just shade outside of A and inside of this part here. I'd shade outside of A in total. So let me just. So all of this. Oh, I need this too. Yeah. Well, I like highlighters for this. Colored pencils are good. And like I said, when we do an assignment on this, I'll make those available to you. But highlighters really do the job nicer. Doesn't look much different on paper if you use a highlighter than what I did here. All right, so that would be the set of not A. All right, that whole box represents all possible outcomes that could exist for the experiment. All right, so in this scenario that I made up, it would be any color shirt that anybody could be wearing at any time. All right, so it allows for every other possibility, not wearing a white shirt or a white sweatshirt. All right, and if I define A as a white sweatshirt, then a white T-shirt wouldn't satisfy that. So that would be in the set of not white sweatshirts. You know, it depends on how you define things, right? Because what we're working towards, among other things, is being able to categorize as, well, I'll call it the haves and the have-nots. It's really the idea that you could have 100 different outcomes, but you could organize it so that it's into two groups: the stuff that you want and the stuff that you don't want. All right. So, you know, like you think about all the different types of weather that you could have, but I could simplify it down to it's either raining or it's not. All right. So keep it simple that way. It makes the probability easier to work with. You focus on, it's kind of like a controlled experiment. You focus on the thing that you want to test, and everything else is not that and needs to be accounted for. Right, but then you get problems like this, and I'll just do one of them so that you get some time to go back to studying. But if I want to take, for example, A and unite it with not B, sometimes it could be a little tricky. Some people could do it very quickly and easily without drawing like side sketches, but I like to do side sketches. So what I'll do is I'll just draw a box. I should just turn the shading off. I hardly ever need it. Oh wait, where's the shading option? Fill color, that's the one I want. All right. Like in the rare circumstances where I actually want it, it doesn't make it worth it to have it on all the time. Although it does look cool. It's just not ideal. All right, so copy this. Paste it here. All right, so this is, call it like an emergency situation. So like if I can avoid doing what I'm about to show you, I will, just because it is kind of tedious. But if I can't avoid it, because I can't figure out what the commonality is within a set, whether it's an overlap or an absorption kind of situation, you know, then I tend to want to draw it out. All right, so what we're doing here is we're looking at sets A and B. Do it a couple times. This first piece, I just want set A. Or I'm sorry, the first graph, I just want set A. So I just highlight set A. We get a nice blue here. All right, and then I want set not B. All right, so everything except for B. All right. So I have my set A, my set not B. What I would be looking for is not, because this is a union, I'm not looking for overlap. I'm looking for, when I combine these two diagrams, any part of it that has any kind of shading whatsoever. All right, so when I put this on top of this one, I look for any shading that might exist. All right, so really, it's only that like crescent moon part of B that's not shaded. So everything else would be part of the actual set. All right, so I'm able to determine what parts of the diagram are relevant by merging them together. right? So again, it's two separate things. Put it together and just take note of any part that is shaded. Right, I'm going to leave them separate though. So everything except for that crescent moon there. Now you could shade it any way you want. I mean, if you want to use the like cross hatching technique, that's fine. You know, old school. Or get a nice highlighter going. I don't think the yellow and blue I chose would make this shade of green, but we know that yellow and blue do make green. Some kind of green. And so this would be my solution. All right. So anything out of whatever set you're dealing with that isn't just B alone. Right? So if I'm going back to the dice, if I say, you know, like I come up with an example that has some overlap, like the, you know, odds and prime numbers. Right? So if I say odds are the set of A and prime numbers is the set of B, then I'd be looking for anything that would just be not a prime number. So just be a composite number, right? Only. Can't be anything else out of the possible categories.
So if it were like the A and like the upside down U and then like the not B, would it be whatever's like double shaded?
Exactamundo. Yeah, so that would be, oh, that's not my lasso. Double shaded would be that little crescent moon in A. And that would be it. And so that would be your answer for the next one, because it's the same. That's essentially that question. So, well, I don't need this anymore. But that would be just this little crescent moon. I'll go green. Oh, actually, no, it'd still be yellow. In A. All right. So at this point, I'll leave it up to you. If you want to continue working on this, you could try numbers 3 and 4, or you could go back to studying for the free response for tomorrow.